Hi, and welcome to the third of three videos for section 10.3, I believe we are on now. Yes, 10.3. Sorry about that. I didn't forget to erase half the board. I left it here for a reason. And because in this video, we're going to be talking about row echelon form and reduced row echelon form, which going forward I'm going to abbreviate as RE. I don't want to have to keep writing row echelon every time. So the definition: a matrix is in row echelon form if following three things happen. The first non-zero number in each row is a 1. Second, the leading entry, and this actually here, so in number 1, each non-zero number is a 1, and this is known as the leading entry. So the first number in each row is the leading entry. Number 2, the leading entry in each row is to the right of the leading entry of the row above it. And 3, all rows of only zeros is at the bottom of the matrix. That's why I left this up here. This, we used Gaussian elimination. This final matrix that we have, this one here, is actually in row echelon form. We don't have any rows with all zeros. So what that means is that each leading entry, the first non-zero number, is a 1. And every 1 is to the right of the leading entry above it. So basically along the diagonal. So when we have all zeros in the bottom corner and all 1s across the diagonal, or if we have zeros that's only in the bottom row, that is row echelon form. So that matrix we did there is known as row echelon form. A matrix is in reduced row echelon form if, first off, it's in row echelon form, so I have to have zeros and I have to have 1 on the diagonals, and 2, every number above or below the leading entry is 0. So in addition to this the corner being 0 and all the diagonals being 1, everything above and below this 1 would also have to be zeros. And so to get it into reduced row echelon form, we do the same process we did to get it here, but now we work our way back up. We use row 3 on row 2 and 1, and then we use row 2 on row 1 to try to get zeros into that triangle. So let's look at an example. I'm going to erase all this now. And again, the row echelon form is essentially solving by Gaussian elimination. So I'm going to erase this. If you need to catch up with the writing, go ahead and hit pause real quick. That red doesn't erase very well. That's good to know. All right, so let's tackle this example here. So solve using row echelon form. So it's like what we just did. Get zeros in the bottom corner, 1 on the diagonals, and then use back substitution. We have the following. 4x plus 8y minus 4z equals 4. 3x plus 8y plus 5z equals negative 11, and negative 2x plus y plus 12z equals negative 17. So I know you just learned in video 2 how to do row echelon form and back substitute, but give it a try here. Again, it doesn't do you much good to just sit there and watch me solve these. I know how to solve them already. That's why I'm doing these videos. You're the one that needs to know how to do it. So convert this to an augmented matrix, use your elementary row operations, see how far you can get. If you get stuck, fine, and hit play again, but at least give it a try. So I'm going to start working this, but hopefully you're hitting pause and you're coming back. So welcome back. So if I put this in a matrix form, I get what? 4, 8, negative 4, 4, 3, 8, 5, negative 11, negative 2, 1, 12, negative 17. So I want what? I want zeros in this corner and ones along the diagonal. Well, the first thing I'm going to do, if I want to get a 1 here, fortunately, I can divide row 1 by 4. So if I do that, I end up with what? 1, 2, negative 1, 1, 3, 8, 5, negative 11, negative 2, 1, 12, negative 17. Now, I want to work on getting zeros in this portion here. Use row 1 to get zeros in row 2 and row 3. Just checking my battery. I think we might be in trouble, but let's see if we can get this done. So I'm going to go kind of quick then. Make sure I don't run out of battery life here. So I'm going to do row 1 times negative 3 and add it to row 2 to give me a new row 2. So when I do that, I get what? Leave row 1 alone. 1, 2, negative 1, 1. So I'm multiplying by negative 3. Negative 1 times negative 3 is negative 3 plus 3 is 0. Negative 6 plus 8 is 2. 4 plus 5 is 9. Negative 3 minus 11, negative 14. Goof this up. Negative 3 times negative 1 is 3, plus 5 is 8. So second row should be 0, 2, 8, negative 14. Now I want a 0 down here, so I'm going to multiply by positive 2. So row 1 times 2 plus row 3 gives me a new row 3. So 2 times 1 is 2 minus 2 is 0. 4 plus 1 is 5. Negative 2 plus 12 is 10. 2 minus 17, negative 15. So that's good. I see that I can do what? I can divide row 3 divided by 5. That'll get me a 1, and then I can switch these guys. So I'll do it. So 1, 2, negative 1, 1. Leave row 2 alone. 2, 8, negative 14. Divide row 3, so 0, 1, 2, negative 3. Yep, that's fine. So if I switch these two rows now, I get 1, 2, negative 1, 1, 0, 1, 2, negative 3, and 0, 2, 8, negative 14. So the last thing I need to do, get a 0 down here. So I'm going to do what? Leave row 1 and 2, so 1, 2, negative 1, 1. Leave row 2, 0, 1, 2, negative 3. I'm going to multiply row 2 times negative 2, add it to row 3 to give me a new row 3. So when I do that, 0 plus 0 is 0. Negative 2 plus 2, 0. Negative 4 plus 8 is 4. And 6, positive 6 minus 14 is negative 8. So lastly, divide row 3 by 4. So I get what? 1, 2, negative 1, 1. 0, 1, 2, negative 3. 0, 0, 1, negative 2. So that means what? From this last row, I get z is equal to negative 2. And again, I don't want the battery to die on us here. If I do back substitution, so I get y plus 2z is negative 3. So that means y ends up being 1. And from this first row, x plus 2y minus z is 1. Tells me that x is equal to negative 3. So my solution set is negative 3, 1, negative 2. Again, hopefully I didn't go through it too quick. I'm just concerned battery life is dying on us and I was going to cut you off. But that's it. So 1, 2, 3, 4, 5, 6 steps. Some back substitution gets us our solution. So come on back and we'll look at video 4 for section 10.3.